Now let's solve this differential equation. In this question, we are told that it is an Euler homogeneous equation. Therefore, there is no need to prove that. So we just go ahead and solve y plus t all over t. Now, for every Euler homogeneous equation, we need to find a suitable substitution for it. Whenever you are finding a substitution, it is always advisable to multiply by 1, the numerator by 1 over t to the power k. Then the denominator too by the same thing, 1 over t to the power k, where the k is the degree. We know that it is homogeneous, but the question is that it is homogeneous of which degree. So we have to look for that degree of the degree at which this function is homogeneous. Now we can see that y is to the power 1, t is to the power 1, and t is also to the power 1. So each term here is to the power 1. Therefore, we can go ahead and say that this homogeneous equation is homogeneous at degree 1. So it means that we rather we have to multiply each term by 1 over t to the power 1, which is the same as 1 over t here. Then we also multiply here by 1 over t is to the power 1, is the same thing. So we are going to get y prime is equal to y times y times 1 on t will give us y on t here, plus this will give us 1, all divided by t times 1 on t will give us 1. So there's no need to write that one. So we are getting this as our differential equation. From here we can let u be equal to y on t. Make y the subject. We have y is equal to ut. Now let's find y prime. To differentiate this one, hold u and differentiate t, you get u plus, I'm using the product rule, plus hold t and differentiate u, you get u prime multiplied by t. So we are going to substitute this and this into the differential equation. So that is going to be y prime is u plus u prime t should be equal to y on t, and we know that y on t is u, so u then plus 1. So from here we need to simplify. There is u here, it will cancel out. So we have u prime of t, this u will cancel this u. So we have u prime of t is equal to 1. And when you get to this point, remember that u prime is the same as du dt. That's the meaning of u prime multiplied by the t should be equal to 1. Now let us divide both sides by t. I'll get du du dt should be equal to 1 over t. Then the next thing is to multiply through by dt, and I'll get du is equal to 1 over t dt. So next thing is to, now you can see that this one is in a separable form. All the u's are to the left hand side and all the t's are to the right hand side. So we can integrate this and also integrate this. If I integrate du, I will get u should be equal to, if I integrate this, I'll get the natural logarithm of t plus c. But remember that u is equal to y on t, so we can substitute that here. So we have y on t should be equal to ln t plus c. Then I can multiply through by t. If I multiply through by t, I'm going to get y. Y is a function of t, should be equal to ln t plus c, all multiplied by t, all multiplied by t. Now let us simplify this further. So to simplify it, I have y of t should be equal to t ln t plus ct. So finally, the answer is going to be y of t multiplied by t ln t plus tc or ct. And that is the solution to the differential equation.